Today I'm going to be talking about infrared sensing in pit vipers, presentation by Xander Jones. So first we start off with just what is infrared in a basic sense. Infrared is a wavelength of light that is imperceivable to the human eye. So if you look at this diagram here, you can see the visible light spectrum is this tiny little section, and this is what we see. And infrared lies right outside of that spectrum. The wavelength level is just outside, and it ranges from about 780 nanometers to 1 millimeter. So you can see that right there. There are many species of animals that can see infrared or sense infrared, and some of them are obviously the pit vipers and some frogs, certain kinds of fish, bugs as mosquitoes, jewel beetles, mantis shrimp, and then even vampire bats. And some have speculated wolves and foxes, but they don't fully know yet. They haven't done enough studying on that, but I'm going to be talking about pit vipers today. So the way that it works is pit vipers sense it through a special organ called the loreal pit, which is located between their eye and their nostril. These pits allow them to sense light from heat given off by objects. So over here in this picture you can see nostril, their eye, and this pit right here is the loreal pit, and they have it on both sides. And that's where the light given off from heat gets sensed in that section. The loreal pit is this right here, and this is a hollow chamber made up of thin, heat-sensitive membrane, primarily made up of nerves and blood vessels. So when the heat light comes in, it comes in this outer cavity opening on the lip, hits this pit membrane, and then it gets sent down the trigeminal nerves to the brain. This entire thing is housed inside the snake's maxillary bone, which is inside of the skull. Obviously, there's a big benefit to having infrared sensing, and this allows them to see heat outlines of prey and predators in the absence of light. This increases their hunting ability and successfulness and survivability, allowing them to be able to sense when there's predators around or when their prey is nearby. Since pit vipers don't actually chase hunt, they sit still and camouflage themselves and wait for the prey to get close enough to them, and then they strike. And this allows them, even in complete and total darkness, this allows them to still be able to see. They mix the heat sensors with their own vision, so it creates like heat outlines basically. So they still see everything they get with their eyes, but then their brain morphs their vision from their eyes with the infrared sensing to create, the infrared sensing. This is a hyperlink right here for a YouTube video that you can go and watch of BBC. They use the military's infrared sensing, so it's nowhere near as good as what the snakes have, but it gives you an idea. And this is a screenshotted picture from that YouTube video. So you can just get a basic understanding of what it looks like. So the main gene that is involved in this is the TRPA1 gene. It's the main one that's associated with thermal sensing, and non-pit vipers don't express this gene as much as pit vipers do. This graph is showing all these are genes that are expressed with amino acid chains, and this magenta one right here is the TRPA1 gene, and the blue bar shows the number of the gene expression, and the orange line is the proportionality of the gene. So you see the highest one that gets shown is TRPA1 gene, which is the main one when it comes to show that this is the main one in terms of overall thermal sensing, and it's a lot lower in non-pit vipers. So basically, overall, these snakes have evolved much further than their sister species, and the reason why they evolved this is just because it gives them such a benefit in terms of hunting and survivability that the other snakes don't get. It's a larger advantage, and it increases their survivability, which leads to a higher reproduction numbers, which allows them to live in much more vast environments, and you see them all over the world now because of their high success rates, partially due to these heat sensing organs that allow them to be better hunters and survive in worse environments. Um, then this is my citations page. Here's the YouTube video from BBC, the link, and then I got the graph and some of my information from this article here with the link, and then pictures are from Google, and then yeah, diagrams from the same article. Thank you.